Hey everyone, today I'm going to do a video on another parametric precedent. I'm going to be making a series of videos because I will be out of the country in about a few days, so I want to stockpile on videos and leave them unlisted and then just list them and then make them public as I go. I'm pretty transparent about these things, I don't just hide anything, so that's what I'm doing. So yeah, let's just get started. So this one will be, what's it called? The Expo 2015 in Milano, I think it was called. It's this. So I haven't actually modeled this at all. This is me just kind of going out there right now and just saying, I want to do this, how would I do it? So I'm going to walk you guys through my thought process, because usually when I make these videos, I make the precedent ahead of time so I can kind of explain it a little easier, give you guys a little backstory on how I did it and things like that. So, but we're going to just jump straight into this, sorry. And, but yeah, so my initial thought process right now, I'm just going to explain everything that I'm thinking literally, is that this looks really like a controlled range of series and lofts, along with these kind of parametric sticks right here. That kind of, I think it would more be like a divide surface. So we're going to keep this as a surface, as from what I can see. So that's my initial thought process right there, and we're going to be referencing it a few times. So actually we're going to be in perspective view. So for the sake of this, we're going to only model, I think, one of them, but maybe I'll do a series. Actually, no, because there are a series of them, so no, I'll model, I don't know, because like, I'm thinking how I'm going to do this. So the way I'm thinking about doing this is if I have a series of circles on a plane, and then because the series have to be different in order to be, because they're like, how I'm thinking about it is these are differentiating heights. So when I do like a move series, each move is going to be different. So I'm thinking, how would I make them different in terms of that? Maybe almost randomized. I can try that. All right, let me try with multiple of them. If I can't, then I'll do a singular one. But so the way we're going to start, at least I'm thinking of starting, is I'm going to start with a plane. And then we're going to have our plane here. And we're going to probably, after that, do a populate tool. Populate 2D, region, and then instead of a count 100, we're going to make it a count like 5. Something pretty small. 5. Alright, that looks pretty good. And then we're going to do circle. And plane. And there we go. So now we have our circles here. I don't know why this is so big. Hold on one sec. There we go. So now we have our circles. Once we have our circles, now we can think how we're going to randomize the movements. So I'm thinking, I know I need a random command, so I need to put that in there. So, so in a random command, we get a range, number, and seed values. This is just the same thing as this. It just changes the iterations. So we have range. Our locally defined values is 0 to 1. What are my units? I think it's feet. If it'll load, come on. Alright, it is feet. So our range, our number, some locally defined value. Oh, I can do list length. Nope. List length. And this will list how many are in that. So it should be 5. Range. One locally defined value. Oh, number of random values. So this should be plugged in here. The range should be a construct domain because we're creating a domain. And we'll say 0 to 5 feet right now. That will be our start. And actually, we're going to make this 1 as well. So we start with our random commands. So we're going to do a move. And then we know we want it to move in the z direction. So we're going to do that. After we do that, we are going to do a series. So this is where it starts to get a little funky. I'm going to put it to move, plug this in the series. What the hell? Why is this one up here? But are these pointing up? No. Why is this one moving so high up? What? Alright, let me look at my list. Maybe I'm reading something wrong. Alright. So, if I look at this, it's just 5 circles. Okay. And I see the output here. It's like 9 circles. Oh, because I plugged in the series. But, shouldn't they all be... If I plugged in my series, I'm moving it as start 0. My step is 1. And my count is 10. So why are not all of them 10? I think they're not all... Oh, I think I may need to graph them so they read independently from each other. That could be it. I think that's it, actually. Let me check. Yep, alright, cool. I was like, what in God's name is going on? So, now they're all reading independently from each other, which is nice, which is what we wanted. So, if we plug this into here, we can see that we have they're independent. So each one is going to do a move. So a move command to here, a move command to here, 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 and here, and so on. So what I want to randomize is not the count, is the step. And I know I want it to scale as well. So I'm actually going to make them all even first before I plug in this randomize command into the series. So what I'm going to do is do a scale. Actually, I'm going to do an area first of all of them. Excuse me, area. Then we have our centroid. So we know our center is going to be here. We have our geometry, and then we're going to plug in. What is this going to be? Let me think. So we know we need a factor, and the factor will be scaling upwards. So what I'm thinking is we keep it pretty consistent with a range. What range is it? A range component, and then add, is it range? I cannot remember. I'm blanking out right now. Or is it a series? Sorry, we can do a series. Blanking out because it has 0. I think that's why. Let me think. So start step count. So the start's at 0. The step will always be the same as whatever this is. So this will make it, this will move it randomly. So if I plug this in, yep, they're all moving varying height, which is fine. That means this will be plugged into here, and then the count will should stay the same as well. Let me move that up there, it's confusing me. So we can plug this into here. So right now, it's reading a count of 10. The number is 10 times, so should I make this 2? Let me see what that does. So what that does is, this will expand each. Because I want each one. I start at 0. What is it? Not something about cannot scale with. Oh, I should probably show you guys. Cannot scale with factor 0. That's fine. So right now I have one that's small. So I want to control which one it is, and I probably want to do a range. The range is actually probably my best bet instead of a series. Construct domain. Plug this in here and change this to 2. Okay, so these are all. Oh, let me turn off all this crap here. So I can circle. I can also turn this off. Okay. So these are making doubles for I think I know why. Okay, so I know why. This is 10. Let me unplug this. 10 and 2, so this is 10 as well. There should be a total of, let me think, because it's making doubles of it, that means I have 1 extra. So if there are 10 circles, there should be 9 steps? If I'm mathing that correctly? Yes. Yes. Alright, so it really depends on this number, so let's change this to 11 so we can get a count. So we got 11, and then we do a subtraction. Now let's prove my theory right. 11 minus 1, which is here. Plug this into here. So I did 11 minus 1 because of how the geometry fits together, because if we think about it, and I'm going to do this real quick on Rhino. Alright, so I have this many lines. So if I have 4 lines, and I want to count the amount of spacings between it, I'll do 1, 2, 3. So I can take the formula that this minus 1 will give me the spacing. So x, which is, so we can say x minus 1 will give you, x being the number of pieces you have, or individual parts, minus 1, which will give you the spacing. So you can actually, in here you can do an expression. I don't know how to do these exactly very well. I think I'm going to do x minus 1. Okay. Variable x and variable y. There's no y, motherfucker. I'm not very good at these expressions. I'm still learning how to do this. Not very good at it. But anyways, to get on with it. If you don't have to use one of those, don't. It's just my opinion. But so 11 minus 1. Let's get back to it. Delete these. 11 minus 1. So these are way higher. But you see these aren't even. They're all more pretty dramatized at the end. So we can try to do that. They're not cone shaped. So we can actually change the number of steps lower, I'm assuming, to 5. If I do, I want to keep them all consistent. So I want to keep them. I want them to have the same amount of circles because that will make it nice and even. So what I'm thinking of doing is actually not partitioning. How am I on this? Let me see the list real quick. I'm going to chop off. Let me look at the maths or the list set. I'm going to chop off part of it. I want to split my list. Yep, correct. So I want to split it. List A. So the index is the number I want to split it by. So let's split it at number 6 or number 7. So now we have list A and B. Let me disconnect this because it's confusing me. So we have list A and B. How this works. So just plug this in. And now we have 0 through 6 instead. I split it by, maybe this is the wrong one. So I split it by 7, so I should have the remainder 3 or 4. Yeah, remainder 4. Because 0 counts as a number, so technically it's 11. I got a job offer. Okay, cool. So let's think about this. So now we have our circles. We can plug the area into here. And I actually want to see these. So these are the last 4. And we can do a scale of those. And we know that there's going to be 3 spacings. So we can plug that in here. And we can also, what's it called? Do I want to say geometry? Geometry. I think we can just do that. There we go. And this is scaled at 0 to 2. So let's make this 1. And there we go. So we can now exaggerate that kind of cone shape we need on the top part. And we can randomize it by making it not 5, because that's a little high. There we go. 2 is fine. Alright, cool. Alright, we're getting somewhere. So now we have our domains. We know this is 3, so what we can do is we can do a list length, plug in our thing in here. So we have 5. Shouldn't it be 4 then? Or it's going to do it. Let me see. If there is 4, so this is reading 4, so I know there's 3 visually. But mathematically, how is it not? This is reading 5. I'm not too sure. This is reading 1, 2, 3, 4, 5. Yeah, it's reading 5. So how is it creating? I'm confused why this is creating 4 circles instead of 5, quote unquote. Well, my list says there's 4, but this is saying there's 5. If I list the length, it says still there 5. I'm looking at, yeah, I'm not too sure why. 4, 8, 12, 16, it should be 20, 20, yeah. Alright, it's really weird. Well, my list length, because I know there's 4, I can see it in my panel, but it's not telling me there's 4. So that's the confusing part for me. Yeah, this is saying 5 as well. I don't know what I'm missing here. Am I missing something like really off? I don't know what I'm missing. Let me look at this. No. I don't care about the values. I care about the numbers or the amount here. So right now it's reading 5 or 4, but it says 5 values. I'm just slightly confused on that. So you see 20 locally defined values, and there's 5, and it says it's 4. 1, 2, 3, 4. Okay, I'm not going crazy. 1, 2. So there's a list length. I think if I it's reading the amount here. 1, 2, 3. 1, 2, 3, 4, 5. Okay, that makes more sense. It's listing the length of the partitions and not the actual length of one segmented partition. Well, that's annoying. Alright, so I think I haven't used this before, but I think if I simplify it, it will read correctly. No, it still reads 5 to 5 values. Simplify will just give me, let me think. So if I flatten it, it'll just give me 20 values, which is not what I want. If I partition it, it'll give me, if I just know there's 4, but I want it to read it, I don't want to have to read it from, is there a list? That's list length. So this will, if you read the description, measure the length of a list, which is 5 components. I'm seeing if there's like, read one off of one list. I'll read it off of. So I know there's, because if I want to change this in the future, I can by just changing the split values. Well, what I can do, if I know that this is 4 left, if this has 10 or 11, I can do 11. So if I do a list link here, will I get 11? I don't think I will. I'll get 5, but because of partitions. So it's listing the partitioning length, which is not what I want. So if I list out, because I know there are 11 of them because of my series here. So I can do some math. So I know that, so what's 11 minus 7? That's really what I want to know. If it's 4, is it 4? Yep. So if 11 minus 7 is 4, I can actually math it. Plug this into here. And now plug this in here. And then now I want the spacing, so I'll do another subtraction. Awesome. Okay. We're getting somewhere. I was just trying to... I speak out when I'm in my thought process. I speak out everything I say. So it didn't make sense to me, but it's reading the partitioning list. So if I flatten it here, it won't solve anything. It'll just say I have 20 values. If I graphed it, that also won't change it because it still says I have 20 values. So it won't read like the individual, how many there are in one partition, which is kind of annoying. I mean, I can look at it, but I'd rather find a way, a component that will tell me that. Okay, because I use list length for random a lot. I list a length and it'll tell me how many they are within that list. So now what I can do is exaggerate this as much as I want. I can kind of expand it out. So it starts at 0. Let's try that. So right now we have our list, and I'm actually going to save this now that I think about it. Alright, let me get some water. Sorry. I am excited right now, because after this video I'm going to make some grilled cheese. It's going to taste good. But anyways, go to kinetic architecture. We'll name it Expo 2015 Milano. So now we have our scaled geometry. We can now loft it. We can now loft. We can do these two. So we're going to do a merge of this data stream and this data stream. So we get that, and we can plug in the curves. Okay, so we're not getting it correctly, that's for sure. So that also didn't work. So I thought usually flattening it helps, but let me see what this list is reading. Okay, so it is partition, but it's reading... Oh, I see what it's doing. Okay, let me... So what it's doing right now, it's doing... I want the 1 foots and then the 2 and the 3s down here at the end. So I probably have to reorganize it to be... sort list. Is there a... There is... I just sorted it, but I'd rather... Maybe I don't have to do that. Why would I merge it if I could just double opt it? So I can just do the geometry and then this scale. Yep, okay, never mind. I can just do that. What was the point of making it complicated when I didn't have to? So I don't, maybe it could be the quality. So I turn it to high quality, and it looks more like a funnel, so I don't like that. So I'm actually going to change this one and make it rational, and change the value of range to be 2 because I don't want it any bigger than that. I'm going to expand it to kind of make it look more a lot less cone shaped and more natural. And maybe I don't like 7, so I'm going to go back to 6, so it affects more of it. And I can actually start to play around with how that shape looks. So it looks something like that. So I like that. That looks pretty good. Well, maybe I can just skinny it out a little bit more. Not that much. Okay, so that looks pretty good. I'll stick with that. And I'm going to now go to here and divide surface. And then I'm going to do an interpolate. So I do technically want that, but I have my circles for that, so that's pointless. So we're going to do a flip matrix. We're going to flip the data around and then put that in here. Okay, so that doesn't work because, you know what? That just doesn't work. And nice, that's not what I want. Alright, so I don't know why I flattened it. That was the wrong move. I have no idea why I just did that. So the flip matrix, it should take the data and flip it, like literally. The list is not reading correctly. Let me read why. All paths may differ. So I don't know what that means. So what I want to do is read like that, not like ring. So let me look at my list. I may have to. Let me think. Because I want it to read vertically, the points. So, I mean, the numbers are the same, it doesn't matter, because he's dividing it evenly, like 10 this way, and 10 this way. So I'm not too sure why it's failing. It's confusing to me, mostly because I don't... I should try. Construct domain squared. Or is it divide domain? I think it's this. And then I go to let me look at different ways to, because maybe I'm doing this wrong. Let me think. What's the easiest way to do this? I could divide the surface up and try some other crap that will make it work, or could I take the original base geometry I used, these circles, and divide them up? Divide and do curve. So let's test it on a fragment right here. So let's do an interpolate curve. And plug that in here. So that's those. Let's try a flip matrix. And then plug this in here. So that doesn't work because of I have no clue why. But Because I think the list is reading differently now, like way differently that I can't just flip it. Maybe I don't need to enter a point. So it's reading each point like this. I want it to read. I don't know. I'm kind of stumped. I'm thinking now. How would I do it vertically? I thought flip matrix would work. Not too sure. This is stumping me. Like if I do polyline, you'll get that. Then you won't get your closed curve, which is easy. Just make it 1. There, bam. Graphing it won't help. I know that. I'm thinking let's run this. Take that and do it's 11 right here. I want 1, 2, 3, 4, 5. I want 5. So how does the list read? I don't know how the list reads at all, so it's one thing I haven't tried out yet. Should read. Oh, I think it should. Yeah, it's like a group of them already. So like, I just do and this one and this one, and then just do that. Flatten. I don't know why that doesn't work. What does it say? Insufficient interpolation. That's bullshit. Let's say I want to, because right now that's reading, what was that reading? Oh, it's grafted. Okay, that makes sense. I'm just reading all those are grafted. So those are my points. I have a ton of them, right? So I would draw. Well, let me start over. I have an idea now. Just better than no idea. So if we do a list item, we get this, which is what we want to an extent. I just want to be able to change the amount of sliders without having to do a bunch of list items. Let me think of a more logical solution to this. Points. I want my points to now read vertically. I don't know what problem I'm running into. I can't think exactly what I'm running into. It's probably so simple, and blanking on it right now. So this will read this way. I can't flip it because it will just read differently. All paths may only differ at a single locus. No data was collected. Okay, let me read this list. So this is 10. Just want the list to read vertically. Like, I cannot think of it. So if I flatten this, it will read, but it won't read correct. Oh, wait, hold on. Maybe I struck gold. Hold on. So this is partitioned. What is this partitioned at? Partition list. Or not this list. Sorry. List length. Okay, so I'm going to list the length here. This will tell me what the size of the how many partitions they are. 25. I'm going to put a panel back here. There's 10. That's not telling me anything. But, so we can say 10. Let's just try that for right now. And then, now we have our, I want to keep that panel there. Actually. Oh, well, I have to flatten it first. Well, I'm going to actually, I want to keep this data here for future reference. So flatten tree. If I didn't want to keep the data, I would just flatten it from here, but yeah. So now we have our interpolated polyline. Nope. Polyline. What the hell is it? Alright, there it is. You dick. This isn't it. So it's still reading like that. Okay, well, that was a bummer. I thought I got it. So what I did was, I thought that if I flipped the matrix and I had it flattened, it's swapping the rows and the columns. So I did that. I flattened the data here, so it would read out, spew out the data that I needed, and then I repartitioned it back. But it looks like it just did nothing. So that's this point. Let me look at this. Yeah, it's the same crap. So maybe I flatten it first. I mean, it's gonna flip nothing technically, because it's flattened, so it won't read anything. So, maybe let me try, if I have this divide curve, and I have this flip matrix, I'm thinking this is flattened, At a certain point, I don't think this, let me unflatten this. If I graph that, okay, that just errored. I flattened the data, as you can see here. I just flattened it. And then I reflattened it again. Then I repartitioned it back. I thought maybe this flip matrix is annoying. It's not working. Boohoo. 9, 8. So I'm thinking if I think I'm close though, because like if I do the flip matrix, if I flip it, because it's reading this. And currently this is what it's reading right now. If I flatten it, it'll read all in one list. Where's my partition off? Should I repartition it? Well, yeah, let me try that, because how many circles are there here? There are 5, right? 5. Yeah, it's still reading like that. Disappointment. Yeah. Even if I partition it differently. Because I thought if I partitioned it to the amount of circles there would be, it would read differently. Man, this is stumping me. I don't know why this is taking so much brain power. It should be really easy. Alright, let me start over. Let's go back to basics. Should have a line, goes all the way up from the surface. Well, technically, if I do it, this is a divide curve. Let me try my divide surface again. That's where it knows where to stop. It won't work if I do this, because that's what I got originally. I may need to Google this, because you know what? I don't know everything. I already tried flattening it, because if I do that, and I do that. Wait. Oh no. 8, 8, 8, 7, 7, 6, yeah, crap, they're reading the same. What's the point of... Oh, when you flip it, it just turns it back to the original partitions. So maybe different partitions will work. Let me try that out. I'm just gonna literally play with the number slider at this point, because I can't think of a different solution at this point. I mean, it makes sense why they all go back when you do that, actually, now I think about it. Okay. I mean, if you flatten it, it won't do anything. I mean, I've used flip matrix before, and it turned out fine. I just don't know what's going on. Let me Google this. All paths. I'm just gonna, actually, if I do this, I can actually just paste it. I have no idea what this means. I'm not too sure. Flip matrix requires, okay, so David Retton, the god of Grasshopper, basically. A Locust specification in case it refers to oh, that makes a lot more sense now. Oh, because there's just a shit ton of them. Okay. So, simplify tree. Let me try that. This is like row. Oh, I get it now. Okay, I get it now. Right, let me. What up? Alright, phone. I just struck gold, so shut up. I may want to just flatten and repartition it. I think that actually may work. If I do, so it reads under one list, because that list is all jacked up. Okay, I think I know, but I'm going to try it first before I even explain it, because I don't want to tell you guys the wrong thing. List panel. Alright. Oh wait, yeah, 0, okay. Partitioned at 11, 10, I can't, I'm gonna say, I'm gonna try 11 first. And then throw a panel. So even if I did that, this won't work. Well, shit. Okay. Is it 11? 0 through 10? 0 through 10? Oh wait, hold on. Oops. 0 through 10? 10, yeah, it has 10. Alright. No, my charger. Sorry guys, my charger is kind of messed up. No, I just had it perfect. Sorry if you guys hear that. So I flipped the matrix, and now, so you guys saw I did the polyline and it's still messed up. It didn't do what I thought it would do. Even if I simplified the original tree, it just didn't want to cooperate. Because I have, okay, so here's what's going on. When you do a flip matrix, it doesn't, if there's a more complex tree, which is these, then it won't recognize that. It'll just be like, what's going on, man? Kind of thing. Because remember, I did split the tree up. Alright, so that makes sense now, why it didn't. So it does work, but it also doesn't work. If that makes sense. It also works, but it also doesn't work. I want to know why it's connecting to the other sides. That doesn't make any sense to me. Because, like, if I partitioned it correctly, it should be... What the hell? That's not partitioned at all. Okay. Well, that makes sense. Maybe I have to repartition it. And the same number. And... Oh my god! I got it! Alright, so I'm going to explain real quick what I just did. I have no idea what I just did. No, I'm joking. I understand it to an extent. No, undo. I want to keep it there. So here's what I did. The reason why the list got so jacked up is because the list here is fine. So I looked this up and I googled. Thank you, David Rutten. He knows somehow everything about Grasshopper because I think he developed it. I don't know his role in it, but he definitely knows a lot more Grasshopper than I do. So thank you to him. Actually, I'll show you guys what I have. So this is what I read online. This explained it very well, very simply, and it's nice. So here he is saying if a locus is a specific location. So for example, the path of 003 has 3 loci, which is like locally defined values. And this path has 1, 2, 3, 4, 5, 4 locally defined, or 6 technically because it's zeros, 6 loci. When you want to flip the matrix, I'm just reading it right now, then all the paths can only differ at a single locus. So like for example, if you have 0, 0, 0, 1, 2, 3, it'll flip this row of loci. Is fine because only the third loci differs. because this is a differentiating one. If the tree is super complex like this, then it does not understand what the hell to do. I mean, it makes sense because it has this loci and this loci, and it's just like, bro, what's going on? Like, it really doesn't understand. So what should have worked was simplify, but I have no idea why simplify didn't work, because when you simplify the tree, that makes so much more sense now when you simplify the tree. Because simplifying the tree should have worked, but limit clouds to image start path. I don't know what that means. But this, I tried simplifying it. 0, 1, 2, 3. But as you can see, we're getting this type of loci. So it's fine to have 0, 1, 2, 3, 4, 5. This is all good. 7, 8, 9, 10. And then we get 1. And that's bad because it doesn't understand what type of loci to flip. Loci is basically these. So if we did a flip matrix, not that. All paths may only depend on one single loci, which is this. So simplified tree should have worked. I want to know what this does actually. Well, shit. Okay, so what I did was I flattened it. So I put it all under one list. So 0. It's all under 0. Then I repartitioned it so it would redo the list in the way I'd want it to. So the loci is the same. And then after that, what this did was when you did the flip data, the flip matrix, it just reflattened it. I don't know why, or not reflattened it. When I flipped the matrix, it repartitioned it in a totally different way. Like it did 1 through 55. It did 56. And I think that number corresponds with the amount of divisions they are in the UV count. If I'm getting that right. So the UV count may be different. So like this may have 55 or something. I'm not too sure why. But either way, what I did was I took that and I repartitioned it into the now new list of 11. And if you can see, it is a flip of this one. So, yep. So I have a ton of panels. Jesus Christ. But yeah. So that's how I solved my problem. Yay! So let's try interpolate. Enter P. Interpol. Sorry, I'm just happy. I got it. I learned something today. Like very useful. I'm assuming for me. So we have interpolate curve. So now what we can do, now that we have that, we can now just modify the kind of counts. So this. Actually, no, we can't. Hold on one sec. I think I did 10 plus 1. So if I plug in 10 on both, right now they're 10. So if I plug in 10 on both, nothing bad will happen. So this is partitioning the list in different ways. So I'm not going to use these points for horizontal. So I'm not using them for kind of horizontal. I'm only using these points to get these vertical lines. I'm only using them to get those vertical kind of lines upwards. So I don't need to worry about the UV count. I can actually just make them both 10, and that will be fine, because I'm planning on using these circles for the horizontal count, because I think that will be easier. So what do I want in more series circles? So this raises the count of circles. This is the step. So this will enlarge in it and make it taller, but it is adding. Is it adding more circles? Yeah, it is. Okay. Alright, cool. So it is adding more circles. So if I wanted to add more circles, I can use this. But I would have to change around these values as well. Kind of these construct domains of the amount of steps they're taking. Yeah. Okay. Alright, now I get it. Cool, cool, cool. Alright, so that was a journey. How long is this? This is 55 minutes of me struggling. So, I'm going to actually do, so I know this is 10. I can do addition, and I can add 1 to it. 10 plus 1 is 11. And I can plug this into here. And I can plug this into here and delete the 11. And then now I can change this to like 100 and then play around with the values here. So we can add an absolute ass load of them. We can add it. So now we have a ton of them. Nice. This is exactly what I wanted. So yeah, let me look at this picture a little more. I think this is good, so we can actually do a pipe. And I want this in inches, so I'm going to do a division, and I'm going to do everything is divided by 12, because I don't want it in feet. So it's divided by 12? Yeah, because I have 1 foot. What is it? That's a 12, so it's 1 inch, right? So if I want 6 inches, I would say, let me make this 12. If I want this 6 inches, it'll be 0.5. Yep. Alright, cool. So radius and grid. I just thought about this as radius, so that means it's a 1 foot pipe, which makes no sense. So I just thought about it. So let me change this down to like something pretty low. Ooh. Alright, so come on, work boy. Alright, that looks more like it. Right now it's evenly dividing the surface up. I mean that's how it's going to work if you have it like this. So, let me change the count actually. This count is pretty high. I don't want it to be 38. I want it to be probably here. My computer is horrible. Alright, now let me save this because this is golden script. Alright, so now I have my articulation of it. These seem a lot closer up though. I don't know how parametrically they did this. Now I'm thinking about it. It's like they have they have this as more bundled. They're very closely knitted. I think they calculated this circle here and here and actually thought about the rigor of it. So I'm thinking, how did they do that? Because this is like a count. They're very close together. Let me think. Because I was thinking if you just divide the surface, it should be even. But I don't think that's the case anymore. But you can't add more points. So I'm looking at this, and they seem pretty bundled together. And I'm thinking, how did they make it so bundled together? So 1, 2, 3. Well, they're not all super bundled, but like they're very close together and they're evenly spaced. I mean, if you had the same, no, let's still space it. Because if you had the same division points, yeah, because if you had the same division points on the circle, it wouldn't make much sense to have so this is 12, this is also 12, so this is more tightly packed. I mean, it makes sense. It's just, Huh. I don't know. Because mathematically, I'm thinking this is one pipe. There should be another dot here, dot here, here. Yeah, there should be like, but this is like, let's say 12 division. There's also 12. It just tightly packs it. I mean, technically, I think if you make one, you could revolve around the whole thing. I don't know exactly. Like, take one and then use a revolve. Just make it 360. I'm thinking that, like a polar array. I think that's the way you're thinking it. I'm going to, I like what I have right now, and I think that's good. I definitely want to explore this a little further after, but I'm going to stop soon because I have to eat, one, and two, I like what I have right now, but it's definitely not. I'm thinking if you just take one of these pipes, let's say, if they weren't reading on the same list, let's say, they were all... Man, I have to keep partitioning this bullshit. Stop it. uh, so, what am I trying to say? So, I'm gonna do the circles. I'll hold it all together. So let me find my circles I'm using. I think it's here. So this is scaled stuff, and this is the geometry. So I can pipe it. I can use the same radius. That's what I have here. Keep it consistent. To hold shift, that's right. Come on, make the pipes. So I do have those. Alright, cool. So the only problem I'm thinking now is, so I have what I have, and I like it, but I want to try to take this a bit further. I'm going to, this is not partitioned, and it's kind of pissing me off because now the list is like that, and I'm just going to partition list size of that, and that. Nice. And do a list item. And plug this in. So I get, what the, oh my god. What am I getting? Oh, sorry. To flatten that. So I'm getting, okay, there we go. If I did a revolve or a polar array, if I did that, the geometry, and now holy shit, nope. Okay, we're not going to plug that in yet because it's going to bog my computer down. Plane, count, and angle. The plane would be like the center. So I can just take my, I could just go to circle here and type an area and reuse the area of the bottom of my circles to do that. Yep. So the plane would be here. Oh, I thought I didn't plug in. I was like, are you kidding me? So the geometry plane. How many count is there? That's a 10 count. Well, that shouldn't be too much. Ah, crud. Well, nice. So this is not what I wanted. That's pretty cool though. That's pretty cool. But that is not what I wanted. Angle. If I did a polar array, that will revolve around that point. And I think that point needs The list is reading like, it's reading, how many? Not flatten, wait, flatten this. Make my trees of death again. 5 locally defined values that item trim surface. So 5, yeah, 5. Literally 5 of them. So I have my 5 centers. I don't know how this is reading. I think it's reading all grafted as well. Oh no. So if I graft this. Wow, that's exactly the same thing. Okay. Okay. So if I grafted that, it would have done absolutely nothing. Okay, that's nice to know. Alright, so polar array. Because I'm thinking, if I just polar array around this point, would it polar array if I did the top? Because I want it to just like kind of do polar array like that around a center. And I think that's the way to do it, but I don't know why I'm getting this crazy stuff. I must be thinking of something wrong again. I can't think of exactly what I did wrong. So if I did 1, 2, 3, 4, 5, and then I polar arrayed it, because I'm thinking it should work, because it's literally saying create a polar array around geometry, like how it is a center, and then you just kind of dash it along. I've used this for complex geometry as well, so I did this for the Al-Bahar facade, the sun, the triangle one. Let me lower the count. I'm curious to see what it's doing. Let me just do 2, because I can't understand what's going on without really studying it. Oh, I don't think I accounted for the angle, because it's doing some weird stuff. Like, these 2 are right, but it's doing some, I think it's doing, what plane is this reading on? Polar, I think XY plane is not wrong. Okay, maybe I have to do XY plane, and then do this, and then do that. Okay, so it's still crazy, insanely retarded. So, okay. But, okay, it's less insane now. It's a less insane. I don't know if that's any better. I don't know if it knows, like, where the confines of, like, where my domains are, like how I am. Does it know how big my axis I want is? I don't think that should be it, though. Right now it's reading sweep angle in radians, starting from plane x-axis. Just this one. Let me understand how this is rotating, because that's one thing I can't understand at the moment. What the hell did I just do? Why is there 2 planes here? Alright, well, I can't really think of this. I don't want this video to last too long either. It's been an hour and 10 minutes. But I'm trying to figure out if I can just do a polar array, because it's really annoying how I really want it to kind of tightly fit together, and not just this extruded form of just divisions of surfaces. But I think I'd create something different, but at the same time, this reads the same as this. If I plug my panel into here, if I do that. The origin, those are my points. I did this for the Al-Bahar script. Let me think how I did that. Because I did polar array, did a polar array off of a point, which is, for me, that kind of XY plane. It should be. Well, let me try I think what I should do is start a little more simple than a polar array. I think I should start more in terms of rotate and just understanding how this is working. And if I do, oh, I have to recreate that plane. 1 second. Oop. So that's rotating like that. Let me try this one's kind of in the right place. But it's rotating like around something else. I want to isolate it to just one now. So I'm actually going to flatten the tree and do a list item. Sorry guys, this video is so long, but I think this is a really good lesson in list manipulation because I've done so much of it already. Geometry. And I rotated it once. Oh, well, I have multiple center points, so I probably need to do that too. Points. Probably just going to use this because I'm really tired of going all the way back here. So I'm just going to shove this here. So point, and I can do list item. Or I don't know what the list looks like, so I may have to look at it first. Oh, yeah, I can. Oh, okay. Okay, cool. It's the same one. Alright, and then do plane. And then delete. And this will error it out. Fine. 2, 2. Yeah, okay, cool. So that works. Alright, let's try now. Instead of that, we can do all of those at once. So that works. We can try polar array now. I'm not going to plug in the geometry yet. This is grafted, so I may graft it as well or flatten it. I'll probably just flatten it. And then I will just go to plane, which will be my point here. I'll keep the count at 2. and I'll do radians, degrees. I'll plug this in here. I'll make this 45. I don't know. Okay, so this is reading like that. So it worked with rotate. Hold on, let me put back that rotate crap I had. That actually worked. So this is what I have. List item, and I'm messing with one of them, and I'm literally rotating it around. You can see. This is in radians, of course. Or no, this is... I don't have a degree. Should it be radians? Oh, I must be messing up quite badly. I was like, what's going on? So I'm going to look at this one. I'm going to isolate it to this one. And just... I'll make it 100. Oh, here it is. So what it's doing, it's rotating around that axis right here, which it should be. Now, let me try with not just a list item, but a group of them. Now, I don't know why it freaks out when there's more geometry. It doesn't make much sense to me. Like, it's just one. It's just one of them. So it's like, I don't know why it's freaking out. It's only one type of articulation happening. Oh, maybe because they're rotating around one center. Mine's rotating around this one. They're not independently reading as rotating around that one center. That makes sense now. Okay. Can you do that? Okay, you can. So it's still reading around a center. Like you see, it's rotating around the center. Like this one is rotating correctly. This one isn't, and this one isn't. Huh. This is just, it's a strange problem because I've never really seen this before. So I'll probably make this a two-parter because I want to go eat. So yeah, I'll leave it at that. This is another problem, quote unquote, but I'm honestly happy with what I have here to an extent, how these pipes fit together and how this is. So yeah, I have that worked out, but I'm definitely going to try to explore more with the polar array because I'm a little finicky on that, as you can tell. So yeah, guys, let me say this. So yeah, guys, that's it for the video. I'll have a part 2 for this parametric precedent since it's a little more, not complicated, it's just a list intensive heavy, which I'm definitely still learning. So yeah, guys, thanks for watching. Hope you guys have a great day. Bye.